All right, this is the review assignment from class that we looked at on Thursday. So the first one, we have a vertex. We're given the vertex. So we have the x value and the y value. We need to sub that into the equation to create an equation. So we will always take the y value, drop it over here at the end, and again the y value does what it's supposed to do. If it's a positive 4 as a vertex, it's going to be positive 4 in the equation. Now the x value though is the one that does the opposite of what we want it to do or think it should do. So negative 2, 4, if we graph this, our vertex is going to be right here, meaning our graph has shifted left 2 and up 4. But in our equation, a positive 2 is what actually shifts it to the left, and a positive 4 shifts it up. So that one, again, is the opposite of what we see. When we see a plus 2 in the equation in the middle, that's going to signify a left shift. And if we had seen x minus 2, that would have gone to the right. So some key features: the vertex obviously was given to us. It's negative 2, 4. Axis of symmetry, remember that's always x equals, and it's always x equals the x value of the vertex. So I don't have to do any more work there to know that that's going to be negative 2. I can come in here and draw in my axis of symmetry then at x equals negative 2. Y-intercept, a couple ways to find it. One way would be to convert our equation to standard form. Another way, though, is to simply take the equation 2 times x plus 2 squared plus 4 and substitute in the x with a 0, because the y-intercept is the y value when x equals 0. So if we come back and go 2 times 0 plus 2 squared plus 4, and then in the parentheses 0 plus 2 is just 2, and then we do our exponent before we multiply, so 2 squared is 4. Now we can multiply and add. 2 times 4 is 4. 8 plus 4 is 12. So y equals 12. So when x was 0, y is 12. And that becomes our y-intercept. And I can plot that thing right here. And because of my axis of symmetry, I can plot another one over there. And because this a value is 2, which is positive, I can say this opens up. Not ups, but up. We can also tell it opens up because we plotted our y-intercept. So the question about what transformations did you make? Again, x squared would be in this area. So we went left 2. We went up 4. And because of that, because a was 2, because a equals 2, we also have a skinnier parabola. Remember, when a is greater than 1, it gets skinnier. When a is less than 1 but greater than 0, it's wide. What we need to make the quadratic open downward, that's always the a value. The a value would need, can't write, would need to be negative. So like negative 2, x plus 2 squared plus 4. What would we need to be wider? Again, I'm going to focus only on that 2. That's the only thing that matters for the width here. So what would be wider than that? Anything anything smaller than 2 here. So 1/2 x squared would be wider. 1.9 x squared would be wider. 1/4 x squared would be wider. We could even get into negative 1.9 x squared would be wider. Rhonda made a common mistake, and this is a mistake that a lot of us made on our quiz, thinking this value is the y-intercept, and we're correct to think that this value is the y-intercept when it's in standard form, but this is vertex form, and so that value, that 7, is not our y-intercept. So again, we don't just assume that this is our y-intercept. So again, we can solve this 2 different ways. I showed you the one way, which would be replace this x with 0 and evaluate. The other way would be to take your x minus 2 and expand it out. So it'd be x squared minus 2x plus 4. So we have 3 times x squared minus 4x plus 4 plus 7. We distribute this through the parentheses. Again, we're just expanding this and creating a standard form equation from our vertex form equation. The last thing to do is just add those 2 together. So 3x squared minus 12x plus 19 is the standard form. Again, from the standard form, then we could say, well, this value tells us our y-intercept, so 0, 19 would then be the y-intercept. We have a question, what is the vertex in this standard form? Again, we find our vertex by doing negative b over 2a, or the opposite of b over 2a. This is your b value, that's your a value, so we're going to go negative 16 over 2 times the a value, which is negative 4. So we're negative 16 over negative 8, which is the same thing as 16 over 8, which is the same thing as 2. So that's the x value of the vertex. The next step then is to take that x value and sub it into the equation for x. So negative 4 times 2 squared plus 16 times 2 minus 20. Again, this part has to happen first because that's an exponent, so 2 squared is 4. We can rewrite this entire thing. 16 times 2 is 32. Negative 4 times 4 is 16. 16 plus 32 minus 20. Or negative 16, sorry. Negative 16 plus 32 is positive 16. Minus 20 would be negative 4. And that's the y value. So there was the x value, there's the y value. 2, negative 4 would be our vertex. Here, create a regression equation. Again, that's going to be going into our calculator, doing stat, then enter, and typing in that data. So we would type in this data in y1, we would type this data into y2, then we would go stat, calculate, and we know this is quadratic, so we would do quadratic regression. And we know it's quadratic because 1, it's a ball, and 2, if you look at the numbers, right, they're going up, 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 then back down, and down, down, down. So we can tell by the numbers this thing's doing this. And the only function we've studied that does that is quadratics. So we don't have to do our first difference, second difference piece because we can tell it's quadratic. And the other issue that we run into by doing first difference, second difference is my x values don't go up by the same every time. This is plus 5, this is plus 5, but this is plus 4, and this is plus 6. So we won't have a consistency in our first difference or our second difference. And again, even though this is quadratic, our second differences aren't going to line up because these values are not the same. So we just analyze the numbers, say, hey, they're going up, then back down. It's doing a parabola shape. It's got to be quadratic, or as we've studied in class, it's a ball. So when you finish that, you'd get an ax squared plus bx plus c equation. If we're asked for 70 degrees, we would put 70 in for x. So we would have a times 70 squared plus b times 70 plus c, whatever our a, b, and c were. And if another ball was hit, modeled by that equation, what is the max height? That's just, again, doing the vertex. So we would do negative b over 2a, which would be negative 48, over 2 times negative 16, which is negative 48 over negative 32, which is 48 over 32, which is 3/2, which is 1.5. So that's our x value. That's the time. So if we start to think about what this thing is doing, it's going up and coming back down. We now know it hits this maximum here at 1.5. Now what we need to know is, what was the y value? So we can do that by taking 1.5, subbing it into the equation for t, and seeing what comes from that. Again, exponent first, so 1.5 squared is 2 1/4. Oops. So 2.25 times negative 16 plus 48 times 1.5 is 72 plus 5. Negative 16 times 2.25 is negative 36 plus 72 plus 7. Negative 36 plus 72 plus 7 is 43. So that's our y value, that's our feet, or our y value. Our coordinate would be 1.5, 43, 1.5 seconds, 43 feet. This value here now is no longer a question, it's 43. Determine if each table is linear, quadratic, or exponential. Determine how you would know. Again, we'll always start with our first differences. Look at those. 3 to 6 is plus 3. 6 to 12 is plus 6. 12 to 24 is plus 12. So linear, no. Second difference is 3 to 6 is plus 3. 6 to 12 is plus 6. Second differences don't work. Quadratic also doesn't work. So next question is then, is it exponential? If we do 6 divided by 3, that's 2. If we do 12 divided by 6, that's 2. If we do 24 divided by 12, that's 2. So we do have that common ratio of 2. So determining the rule here, because this is exponential, this will be a times b to the x. A is the start, which is 3. B is the multiplier, which we can tell is 2. So y equals 3 times 2 to the x. The other option would be type these values into your calculator, y1, y2, and do exponential regression. All right, second one. 10 to 8 minus 2, 8 to 6 minus 2, 6 to 4 minus 2. First difference is worked. Has to be linear. Y equals mx plus b. Rate of change is negative 2. X. Y-intercept is 10. And then the last one, let's look at first differences, down 6. Second difference is down 4. First difference is down 6, down 4, and down 2. Second difference is not linear, because first differences didn't work. Negative 6 to 4, plus 2. Negative 4 to negative 2, plus 2. Second differences work. This is quadratic. So y equals ax squared plus bx plus c.
May I have your attention, please? Reminder that the coffee house is closed today.
And again, the best way to figure out what a quadratic is stat calc, enter the data, stat enter the data, stat calc quad reg. Right, Mr. P? All right, that's it. Bye.